This Physics Medicine online tutorial class organized by Mrs. Okuma I. Today, we want to look at some revision questions in physics. And these questions covers both first term, second term, and third term work. We're going to see some questions, some objective questions. We start with question number 1. A body accelerates uniformly from rest at 2 A body accelerates uniformly from rest at 2 meters per second squared. Calculate its velocity when it has traveled a distance of 9 meters. We take it again. A body accelerates uniformly from rest at 2 meters per second squared. Calculate its velocity when it has traveled a distance of 9 meters. Now, how do we go about this? We start from the known and go to our unknown. Now, from the question, a body accelerates uniformly from rest. That means the initial velocity the body started with, u, is equal to 0 meters per second. Initial velocity is 0 meters per second. Then we were equally given acceleration, and the acceleration is 2 meters per second squared. We were equally given the distance covered, that is 9 meters. And what are we looking for? Calculate its velocity when it has traveled a distance of 9 meters. We are looking for the final velocity v. That is our unknown. Now you remember the equations of motion. From the equations of motion, the one that can help us in solving this says that v squared equals u squared plus 2as. Now we are going to substitute. V squared will give us 0 squared plus 2 times our a is 2, that is the acceleration, multiplied by our distance, that is 9. So v squared will give us 0 squared will give us 0. 2 times 2 will give us 4 times 9. And that will give us how many? 4 times 9 will give us 36. And that is our v squared. So what is our v? Our v is the square root of 36. So that will give us 6 meters per second. And that is option C. So answer to question number 1 is what? C. We move over to the next question. Question number 2. A body weighing 14 Newton in air is partially immersed in water. If the mass of water displaced in the process is 200 grams, calculate the upthrust on the body. G is 10 meters per second squared. We have option A, 2.0 Newton, B, 3.0 Newton, C, 3.5 Newton, and D, 7.0 Newton. Now, how do we go about this? How do we go about this? Now look at the question. A body weighing 14 Newton in air. Our weight in air, call it W1, is 14 Newton. Then, if the mass of water displaced is 200 grams, remember your Archimedes principle. When a body is totally or partially immersed in a fluid, it experiences an upthrust, which is equal to the weight of the fluid displaced. So, the mass of water displaced here, M, is equal to 200 grams. You change it to kilogram, divide by 1000, 200 over 1000. That will give us what? 0.2 kilogram. 0.2 kilogram. Now we are asked to find the upthrust. Remember, upthrust is equivalent to the mass of the water displaced. And remember, upthrust is a force. So, if upthrust is equivalent to the mass of the water displaced and is a force, it will be equals to m times g. So, you change the mass in kilogram, 0.2 times g to make it a force. That is times 10. So, our upthrust, 0.2 times 10 will give us 2 Newton. And that is option A. We move over to the next question. Question number 3. Question number 3. The angle at which a projectile must be fired to cover maximum range is A, 30 degrees, B, 45 degrees, C, 60 degrees, and D, 90 degrees. Our answer is what? 45 degrees. That is option what? Option B. For you to obtain maximum range, the angle of projection must be at 45 degrees. Go over to question number 4. A uniform half-meter rule of weight 42 grams is to be balanced horizontally on a knife edge at the 15 centimeter mark. Calculate the value of the mass hung at the 3 cm mark that is needed to do this. A, 35.0 grams, B, 98.0 grams, C, 122.0 grams, and D, 350.0 grams. Now let's see. Now from the question, we are talking about a half-meter rule. Remember, a meter rule is 50, a meter rule is 100 cm. Here is 0. But for half-meter rule, that is 50 cm. Now, this half-meter rule, the weight is 42 grams. And remember, for a meter rule, the weight normally concentrates at the center. So the weight is what? 42 gram. So if the weight is at the center, that means from here to here will be how many? 25 cm. The center of gravity. Then a uniform half meter rule of weight for 2 grams is to be balanced. Horizontally on a knife edge at the 15 cm mark. So where it balances using your knife edge is at the 15 cm mark. This is my knife edge. So from here to here, how many? 15 cm. Okay, calculate the value of the mass hung at the 3 cm mark that is needed to do so. So for you to balance it, you have to hang a mass at the 3 cm, and that is the mass we are looking for. So here, from here to here, how many? 3 centimeter. Now remember, for moment of a force, sum of the clockwise moment will be equal to the sum of the anti-clockwise moments. And when you talk about moment, you talk about the product of the force times the perpendicular distance to the line of action, that is the pivot. Now let's see what is now the distance from here to here. From the knife edge to the center, that will give us 25 minus 15. So here we are going to have 10 centimeter. Now what will be the distance from mass to the knife edge? That is from here to here. So 15 minus 3, here will give us 12 cm. Now from here, the mass will be moving this way, and that is your clockwise moment. That is the 42 gram mass is moving this way, clockwise, while the unknown mass is moving this way, anti-clockwise. So for moment of force, we say that clockwise moment is equals to what? Anti-clockwise moment. So for clockwise moment, force times distance, here my force is 42 and the distance to the pivot here is 10. That is equals to the other mass, m. Then the distance to the pivot from here to here is 12. So here 42 times 10 will give me 420, will be equals to 12 m. I'm going to make m the subject. Divide both sides by 420. That is 420 over 12 will be equals to what? M. So when you divide, my m will be equals to what? 35 gram. And that is option what? Option A. We take few more questions to be continued in our next class. We go over to the next question, question number 6. A student, question number 5. A student found out that from a simple pendulum experiment, that 20 oscillations were completed in 38 seconds. What is the period of oscillation of the pendulum? Now, remember, for period of oscillation, period T, talk about the time taken to complete one oscillation. Time taken to make one complete oscillation. And here time was given as 38 seconds. Is already in seconds, no conversion. Now the number of oscillation is 20. So we have 38 over 20. And that will give us what? 1.9 seconds. 1.9 seconds. And that is option D. The next question, probably the last for now. The force of 100 Newton is inclined at 30 degrees. Please, this is 30 to the horizontal. The force of 100 Newton is inclined to the horizontal, 30 degrees to the horizontal. What is the vertical component of the force? Now, this force is inclined at what? 30 degrees to the horizontal. So this is the force, and the magnitude of the force is 100 Newton. Remember, this is your y-axis for Fy. Here is your Fx, x-axis, and is inclined towards the horizontal at an angle of 30 degrees. The question says, what is the vertical component of the force? That means you resolve this force towards the vertical. And when you resolve this force towards the vertical, we have that Fy will be equals to F sine theta. If you are resolving towards the horizontal, that is here, it will be F cos theta. So here, my Fy, the force is 100 times sine theta, that is sine 30 degrees. So here I have 100 times 0.5. And that will give me what? 50.0 Newton. And that is option C. So we are ending here for today. To be continued in our next class. Join our ongoing holiday class. Distance is never a barrier. Here we bring physics at your doorposts. I remain your tutor, Mrs. Okuma I.